Today I would like to continue talking about Chapter 3, Lesson 1. Today we're going to cover pages 77 through 79, talking more specifically about the atom and the parts that make up the atom. So your key sentence here is a very important key sentence that sort of wraps all this stuff up into one spot. It tells us that at the center of the atom is a tiny, dense nucleus that contains protons and neutrons, and then surrounding the nucleus is a cloud-like region of moving electrons. That's where we had gotten to yesterday when we were talking about the model of the atom. We were saying that you have the nucleus at the center, and then the electrons are sort of in that electron cloud out around the nucleus. Now we're learning that it is the protons and the neutrons that make up the nucleus of the atom. This represents the nucleus of the atom, again made up of the protons and the neutrons. That nucleus is at the very center of the atom, and then all of the electrons are in this cloud that orbits around the tiny little nucleus that is here at the center. It's important to sort of understand the scope of the size of this, because most of the atom is actually empty space. So most of the space or the volume that makes up the atom is that area where those electrons are kind of whirling around out there in the cloud. To put this into perspective, if the nucleus of the atom were the size of a pencil eraser, and you stood at the middle of Lucas Oil Stadium on the 50-yard line and held that pencil up in the air, your eraser would represent the nucleus of the atom. The electrons in the electron cloud could be anywhere between there and the top row of the seats. Most of that would just be empty space. Imagine if you're thinking of, an atom that only has 4 electrons. So your nucleus is the pencil eraser, and there's 4 little tiny electrons somewhere out there in the rest of the stadium. So that kind of puts it into perspective that most of the atom is actually empty space. Now, to kind of blow your mind a little bit, if most of atoms are empty space and everything is made up of atoms, that means the majority of everything is empty space. So think about that for a moment. All right, let's look at the charges then that the different parts of the atom have. Protons are shown by a plus sign. That means they have a positive charge. Electrons are shown by the symbol, and the text is kind of messed up on here. It's shown by a symbol, E, with a little negative sign. So it kind of looks like this, E with a negative. So protons are positive and electrons are negative. Very important statement here. The number of protons is always equal to the number of electrons. The number of protons is always equal to the number of electrons. So because of that then, the number of positive charges are going to equal the number of negative charges. So those charges then balance each other out. So the atom itself is neutral. Neutrons don't have a charge, so they're not going to affect the charge of the atom at all. So back up here again, we can say that the protons have a positive charge. The neutrons have no charge. We'll put a little 0 for that. And the electrons have a negative charge. So protons are positive, electrons are negative, and neutrons have no charge, or we say that they are neutral. Protons positive, electrons negative, neutrons neutral. If we look at the mass of these different parts, why is this not letting me do this? Here we go. So if we compare the particle masses of these, It takes almost 1,840 electrons to equal the mass of one proton. So protons and neutrons are about the same, and again, those are in the nucleus. But electrons are really, really, really tiny. So most of the mass of the atom comes from the protons and the neutrons. So together, the protons and neutrons make up the mass of the atom. The electrons are kind of insignificant. Remember, those are those little things rolling around outside in Lucas Oil Stadium, with the pencil eraser being most of the mass right at the center. That brings us then to atomic number. Every atom of an element has the same number of protons. So every atom of gold has the same number of protons. Every atom of silver has the same number of protons. They give us an example here. Every carbon atom has 6 protons. Every iron atom has 26 protons. That's always going to be the same. And that's where we get the atomic number. So the number of protons in the nucleus of an atom is the atomic number. When we talk about periodic table later, we will come back and talk about the atomic number. That is the number that you see at the top of each box on the periodic table. That's called its atomic number, and it basically tells you the number of protons. So if the atomic number equals the number of protons, and we already know that the number of protons equals the number of electrons. Oops, let me write. So if the atomic number equals the number of protons, and the number of protons equals the number of electrons, the atomic number also tells you the number of electrons. So when you see the atomic number on the periodic table, that is going to tell you the number of electrons as well. Protons and electrons are the same, but the number of neutrons can be different. So even though all atoms, again, of an element have the same number of protons, the number of neutrons can vary. So atoms that have the same number of protons but a different number of neutrons are what we call isotopes. And that's what they're showing you down here. An isotope is identified by its mass number, which is the sum of the protons and neutrons in the atom. So again, the mass number is the number of protons and the number of neutrons combined. So we can see down here, they show us 3 different carbon atoms. Again, the number of protons will always be the same. An element always has the same number of protons, but the neutrons can be different. When you add the number of protons and neutrons together, that's when you get the mass number. So for example, we know that carbon has to have 6 protons, because all atoms of carbon have 6 protons. So we see here we've got 6 protons, 6 protons, 6 protons. If it's carbon-12, these numbers have to add up. So these 2 numbers have to add up to be this number. So if there are 6 protons and 6 neutrons, the mass number is 12. So if the mass number is 13 and we have 6 protons, that means we have to have how many neutrons? 7. And if you have 8 neutrons and 6 protons, the mass number would be what? 14. We will come back and talk about this a lot more when we get into the periodic table. But the point of this part of today's lesson is just to see that the nucleus is at the center of the atom. Most of the atom is just empty space taken up by that electron cloud where the electrons are whirling around. The nucleus is made up of the protons, which have a positive charge, the neutrons, which have no charge, and then the overall atom is neutral because the number of protons equals the number of electrons always. The number of neutrons is not always going to be the same, and that's what gives us different isotopes for the atoms. All right, if you would go through and fill in the in-text questions for pages 77 through 79. I will also be putting your Lesson 1 worksheet on Canvas as well for you to complete as well. As always, thanks for listening and have a great rest of your day.